Earth is a dynamic planet, constantly changing and evolving beneath our feet. At the heart of this activity lies the Earth's internal structure, a complex system of layers that generates heat and fuels volcanic activity, forces that have shaped the history of our world. The Earth is made up of several distinct layers, each with its own characteristics. The outermost layer, the crust, is a thin, solid shell of rock that forms the surface of our planet. Beneath the crust lies the mantle, a thick layer of semi-solid rock that extends to a depth of about 2,900 kilometers. The mantle is where most of the Earth's internal heat is stored and where convection currents drive the movement of tectonic plates. At the center of the Earth lies the core, which is divided into two parts, the outer core and the inner core. The outer core is a layer of molten metal, primarily iron and nickel, that surrounds the solid inner core. The inner core, composed mostly of iron, is incredibly hot, with temperatures reaching up to 5,700 degrees Celsius, hotter than the surface of the sun. The heat generated by the Earth's core plays a crucial role in the dynamics of our planet. This heat is produced by the decay of radioactive elements, as well as the residual heat from the Earth's formation. The heat drives convection currents in the mantle, which in turn causes the movement of tectonic plates. This process, known as plate tectonics, is responsible for the formation of mountains, earthquakes, and volcanic activity. Volcanic activity is one of the most visible and dramatic manifestations of Earth's internal heat. Volcanoes are formed when molten rock, or magma, from the mantle reaches the surface through cracks in the Earth's crust. As the magma rises, it can cause explosive eruptions, releasing lava, ash, and gases into the atmosphere. These eruptions can have a significant impact on the environment, shaping the landscape and influencing the climate. Throughout Earth's history, volcanic activity has played a key role in shaping the planet. The early Earth was a molten mass, with frequent volcanic eruptions releasing gases that formed the early atmosphere. Over billions of years, volcanic activity has continued to shape the landscape, creating new landforms, building islands, and even playing a role in mass extinctions. One of the most famous examples of volcanic activity's impact on life is the eruption of Mount Vesuvius in 79 AD, which buried the Roman cities of Pompeii and Herculaneum under a thick layer of ash and pumice. This catastrophic event preserved these cities in remarkable detail, providing a unique snapshot of life in ancient Rome. In more recent times, the eruption of Mount Tambora in 1815 caused a global climate anomaly known as the Year Without a Summer. The massive amount of volcanic ash ejected into the atmosphere blocked sunlight, leading to crop failures and food shortages around the world. But volcanic activity isn't just destructive. It also plays a crucial role in the Earth's long-term carbon cycle. Volcanoes release carbon dioxide, a greenhouse gas, into the atmosphere. This process is balanced by the weathering of rocks, which removes carbon dioxide from the atmosphere over millions of years, helping to regulate the Earth's climate. Today, scientists continue to study Earth's internal structure and volcanic activity to better understand the forces that shape our planet. By monitoring volcanic activity, we can predict eruptions and mitigate their impact on human life. Understanding the Earth's internal heat also helps us explore new energy sources, such as geothermal energy, which harnesses the heat from the Earth's interior to generate electricity. So, the next time you see a volcano or feel the rumble of an earthquake, remember that these are the result of the immense forces at work deep within the Earth. Our planet is alive with activity, constantly shaping the world we live in. If you're fascinated by the mysteries of the universe, please like this video and subscribe. There's so much more to explore together.